All right, chapter 5.2, we're going to be factoring quadratic polynomials today. Okay, so factoring, where yesterday we were multiplying. All right, so our objectives are to factor a common monomial from a polynomial, factor trinomials, use patterns. Notice I told you yesterday you're going to want to work on memorizing those. So use patterns to factor special products. And we're going to write and factor quadratic polynomials representing some real-world situations. So lots of things going on. So first up, though, we need to talk about factoring. Factoring is a method of expressing a polynomial as a product. Okay, we have talked about greatest common factor, okay, and factors of multiples and things. So we're going to take this and use this factoring idea to express a polynomial as a product. So doing the opposite of what we did yesterday. Okay, because yesterday we had like 2x times 3x plus 4, right? And we distributed to get 6x squared plus 8x. Today, what we're doing is we're starting with this 6x squared plus 8x and saying like, hey, what do both of these terms have in common? So 6 and 8 have a 2 in common, right? And we have an x squared and an x. So this part of our term has an x. So we're going to take this 2x and we're going to pull it out. So 6 divided by 2 leaves us with 3. X squared, and we divide by x, leaves us with 1x. 8 divided by 2 is 4. X divided by x just leaves us with that. So notice that these are the exact opposite. Multiplying polynomials and factoring polynomials are the exact opposite. They're like inverse operations of each other. Okay. So factoring, it's the opposite or the inverse of multiplying or distributing. And the first step is to factor out the GCF. Remember, the GCF is that greatest common factor. That's what we just did here. In the past, it's been a number. Now it can be a number and a variable, okay, for those. All right, so let's delve in to example 1. We've got 15x squared plus 45x. So what do these two terms have in common? We want to find that GCF. And I like to stair step it. So what's the greatest common factor between 15 and 45? Okay, is 15, pardon me, right? 15 divided by 15 is going to give you 1, and 45 divided by 15 is 3. I don't know why I wrote this, pardon me. So, and then what about this x squared part of the term and an x? Do they have anything in common? Yeah, they have an x in common. So this is what we're going to factor out. Okay. So 15x squared divided by 15x. So 15 divided by 15 is 1. X squared divided by x is just going to leave me with an x. Plus 45 divided by 15 is 3. X divided by x is nothing. So there we have it. We now have 15x times the quantity x plus 3. We change this binomial into a product of terms. Okay, a monomial times a binomial. Now, in B, it's a little bit different. We've already got some stuff pulled out of each of them. The cool thing here to notice is that 3x minus 7 and 3x minus 7, these quantities are the same. We call this a common binomial factor. Okay, 3x minus 7 is a common binomial factor. When that happens, we could say, all right, well, this is going to be the quantity of 3x minus 7. Maybe I should have used the other color there, or a different color there. I apologize if you can't see it. Times the quantity of what's left. Well, they had factored out a 2x, and there's a positive 5 here, so plus 5. And you're done. You now have this polynomial as a product, okay, and we wrote it as a product of two binomials, 3x minus the quantity 3x minus 7 times the quantity 2x plus 5. So like part of the work was already done. We're going to work on getting to this step as well, but it's pretty sweet that it's already done. Okay, so next we want to factor quadratic trinomials. Okay, so when this trinomial is in the form of ax squared plus bx plus c, when a is not equal to 1. Okay, so we're talking here when a, we actually have a number here, when it's not equal to 1. So a could be 7, it could be 42, it could be -5, anytime that there is a number here. So like in this example, we have a 12. In this example, it's a 3. When there's a numerical value there, this is the strategy to use. Okay, so let's look at what it says. It says identify, well, sorry, let me erase that. All right, identify two factors of AC whose sum is equal to B. So that's kind of weird, right? We need to take some time to understand that phrasing. So we want to find two factors of A times C. Well, first of all, we need to do A times C. So our A value is 12 times our C value is -2. So 12 times -2 is -24. So our AC equals -24. Okay. So we want two factors of this number, -24, whose sum, remember that's addition, is equal to B. So let's look at the factors of -24. Okay, so I like to make a list or a table of those. So like -1 times 24, okay, would equal 24, -24. Or we could have a +1 times a -24. That would also equal -24. And you might think, well, this is ridiculous, like, you know, to list both of them out. You don't have to do that later. I want you to understand why it's important. So I'm going to do it. Other factors would be -2 times a +12, or a +2 times a -12. Another set would be a -3 times a +8, or a +3 times a -8. And I have one more, there's one more set of factors for 24, right? We could have -4 times a +6 equals -24, or we could do a +4 times a -6 equals a -24. Now, the reason I listed them both is because it says we're finding the factors, so these are all of our possible factors, whose sum is equal to B. Well, we're going to add these two factors together to equal B, and our B value is a +5. So -1 plus 24 would equal 23, whereas a -1 plus -24 would equal a -23. These are vastly different numbers, okay, but very similar at the same time. So let's go and keep going and checking these. -2 plus 12 is 10. Is a +10. 2 plus -12 is a -10. -3 plus 8 equals 5. Hey, that's what we wanted. We wanted a +5. Notice 3 plus -8 would equal -5, which we don't want. -4 plus 6 would equal a +2. 4 plus -6 would equal a -2. So there's only one set of factors that will ever work. So we've identified them now. Our factors are -3 and 8. Next step then is to rewrite the middle term as a sum of the factors from step 1. Okay. So we're going to take those two terms. We're going to rewrite this middle term because -3, notice, so this is going to be -3 plus 8, right? -3 plus 8 equals 5. We want it to do that. So what we're doing is we're splitting this middle term into two different parts. Okay? And one part's going to be -3 and the other part is going to be 8. Now the way that you write them, which order you put them in, doesn't always matter. I like to group them in ways that I know they're going to match up. Like I'm going to put, so I get, let me change my color up here. So I've got 12x squared minus 3x. I'm going to group those because 12 and 3 have a common factor. And so thinking further down the road, I want them to have common factors so I can factor that out. Okay, and then I'm going to have plus 8x minus 2. But here's the thing, right? Here's my -3x plus 8x. Okay, those came from right here, and they both had an x because it was from the middle term. Should have gave myself a little more room. Okay, so let me get rid of those for a minute. Okay, now the thing to do is we want to factor. We have 4 terms here. The next thing it says, step 3 is group the first 2 terms and last 2 terms. So we're going to do that with parentheses. So we're going to put parentheses around the first 2 terms and parentheses around the last 2 terms. Then factor the GCF from each grouping. Okay, so what is 12x squared minus 3x? What do those 2 terms have in common? Well, 12 and 3 have a 3 in common. X squared and x have an x in common. So 12 divided by 3 is 4. X squared divided by x is x. Minus, right, I've got, so -3x divided by 3x leaves me with a -1. Okay, look at my next grouping. What do they have in common? So 8 and 2 have a 2 in common. So I'm going to take out a +2. And x and no term have nothing in common. So 8x divided by 2 is 4x. -2 divided by 2 is -1. Okay, notice I now have that common binomial, 4x minus 1, just like I had in example 1b. Okay, I have that common binomial factor. So since I have that, I get to bring that down. 4x, that quantity 4x minus 1, I had in common, and my leftovers are 3x and +2. That is, I have just factored my trinomial, okay, and put it into a product of 2 binomials. Pretty sweet stuff right there. Again, you're not going to, you don't have to show all of this factor tree and things. You can think about that in your brain, go from there. But let's try this with b. Okay, so again, first of all, we have to multiply our a and our c together. So our a is 3 times our c, which is -14. All right, 3 times -14, what is that? -42, right? Okay, so this should equal -42. And remember, let's find our b value. So we've got that going in our head. B is a +19. Okay, so we need the factors of -42 that equal 19. Okay, so if you, again, like you could think, okay, well, 1 and 42, well, that's not going to work, right? We're equaling a -42. So a lot of times I will write them out, and then I'll just like remember that it's negative. I'm like, well, that's not going to work either way. Okay, so then I have 2 and 21. Hey, 2 and 21, I need 19, right? So is it going to be -2 and +21, or is it a +2 and a -21? Which of those gets me a +19? It's this one, right? -2 plus 21 equals 19. So here are my factors. 2, -2, so this equals -2 and a positive 21. Okay, so that's going to be super helpful. Okay, so now I'm ready to split my problem, or to rewrite, like split this middle term, right? We're going to split this middle term into two different parts. So here, let me copy it down. I'm going to run out of room though again. So I've got 3x squared plus 19x minus 14. So what I'm saying is, we know that negative 2 plus 21 still equals a positive 19. So we can split these two terms. So I'm going to have 3x squared. I'm going to do plus 21, and I add the x because it's my middle term. It has to have that x on it. Okay? Because 3 and 21 have a common factor, where 3 and negative 2 do not. So then I have negative 2x minus 14. Again, knowing I'm going to group these two together, because I know I'm going to group these two together, 2 and negative 14 have a common factor. Okay, I'm going to use that. Okay, so step 3 was to group them and find the GCF. So 3 and 21 have a 3 in common. X squared and x have an x in common. 3x squared divided by 3x is x. 21x divided by 3x is a positive 7. Okay, so now I have negative 2x minus 14. Well, they have a negative 2 in common, so I can factor out that negative 2. Negative 2x divided by negative 2 is x. Negative 14 divided by negative 2 is a positive 7. Again, I've got this common binomial, x plus 7, x plus 7. So that's my first term, or one term. It doesn't have to be your first term. But I'm going to have that quantity x plus 7. And then my leftovers, what I factored out, is 3x and negative 2, so minus 2. Okay, so there we have it. Again, we factored our trinomial into a product of binomials. Okay, now let's go to the next one. Okay, I was like, it was taking a long time to clear there. Next up, we're going to factor quadratic trinomials, ax squared plus bx plus c, when a is equal to 1. This is actually so much easier. You get to skip a step. Okay, you totally get to skip a step here. So when this happens, notice, right, we don't have a value. There's no number in front of our x squared. And there's no number here in front of our x squared. So you remember that step where we had to find AC? We don't have to do that because there's no A. So what we do now is we just identify two factors of C because there's no A, whose sum is equal to B. All right, so we're going to take our C, negative 21. All right, so we've got C is negative 21, and it has to have factors of B, which is they have to add to be negative 4. Okay, so let me go back here. So I've got negative 21. I'm going to make my chart, which is 1 and 21, 3 and 7. Hey, 3 and 7, right? They're going to get me a 4. So is it negative 3 and positive 7, or a positive 3 and a negative 7? Which one is going to get me negative 4? Yeah, this one is, right? 3 plus negative 7 equals negative 4. Negative 3 plus 7 would equal a positive 4. So we want this set, 3 and negative 7. Okay, so now we're going to write the factors of x squared, as the first term in two binomial factors. Okay, so this is a little bit different. Okay, so we're going to write the factors of x squared as the first term in those. So it's going to be, we're going to take that and we're just going to, automatically we're going to have x times x here. Okay. Then, because this is, okay, these are the factors from our x squared. So we're going to have 1x here and 1x here. Okay. Then our next step is to write the factors you found in step 1. Let me change colors. The factors you found in step 1 as the last term in each binomial. Okay, because we're splitting this one. So we're going to have x plus 3 and x minus 7. And you're done. That's it. And remember, you could always check this to make sure. Like, checking your work is a great thing. So if I had, let's look, x plus 3 times x minus 7, okay, we would FOIL. So x times x is x squared. X times negative 7 is negative 7x. 3 times x is a positive 3x. 3 times negative 7 is negative 21. Combine our like terms. X squared minus, so negative 7 plus 3 is going to be negative 4x minus 21. We got back to what we started with right here. So we know this is correct. Okay, that's how you can check it, because multiplying polynomials and factoring are opposite operations or inverse operations. Okay, let's jump into B. All right, so here our C value is 24 and our B value is negative 19. Okay, so we've got 24. What are the factors of 24 that are going to get me negative 19? So we've got 1 and 24, 2 and 12, 3 and 8, 4 and 6, so what are the factors here? I'm sorry, I was checking my work here and was like, this does not, none of these factors are working. And so I went back and looked at the example and I have a typo here. This is supposed to be negative 11. That would make it a little bit better, right? Like, to know that that's a typo. So negative 11x. Okay, so let's go back here. Which of these factors would give me a negative 11? Now notice, this time I have a positive number, but I have, for C, but I have a negative here. So a negative times a negative makes a positive, right? Yeah, but all of these have to be negative in order for us to get a sum of negative 11. So do you have it, the factors yet? Perfect, right here. Negative 3 plus negative 8 equals negative 11. Okay, so we're going to have, the next step then is to write those binomials where we have x and we leave it blank because we've got our first, we know our first term and that's it. And then we pull in those terms, right? That was these right here. So we're going to have x minus 3 and x minus 8. That is it. And again, to check it, you're going to just FOIL those back out, those two binomials. So x times x is x squared. X times negative 8, negative 8x. Negative 3 times x is negative 3x. Negative 3 times negative 8 is a positive 24. Combine your like terms. You've got x squared minus 11x plus 24. The exact same thing you started with once I fixed it, right? Told you that I had a typo. Okay, so when your a value is 1, it's much, much easier to do. All right. One thing you should remember is you should always try to factor the GCF first. That would make your life a lot easier. So when you're looking at these, do try to factor out your GCF first. So in this case, negative 3x cubed plus 15x squared minus 36x, they all have an x in them, and they're all multiples of 3. So you're much better off to go ahead and factor that 3x out now versus doing all the work with it later. So let's go ahead and do that. We could factor out a 3x. And quite honestly, you could even factor out the negative if you wanted. So you didn't have, and that's probably wise. Go ahead and factor out that negative so you don't have a negative first term, because we don't ever want that in standard procedure kind of thing. Okay, so negative 3x cubed divided by negative 3x leaves us with x squared. 15 divided by negative 3 is going to leave me with a negative 5. X squared divided by x leaves me with x. Negative 36 divided by negative 3 is going to leave me with a positive 12. X divided by x leaves me with no variable. Okay, so that's much easier. And then we're ready to go on and look now, right? This is when here our a equals 1. We don't have a term. So we're going to check 12 and see what sum makes negative 5. Okay, so we're looking for our negative 5. Okay, so I've got 1 times 12, 2 times 6, 3 times 4, not 5. So 3 times 4. None of these are all the terms. The nice thing about this chart when I make it is notice I go 1, 2, 3. My next one would be 4 times 3, but I already have 4 over here. Like if I put them in order, it's easy for me to see like, oh, I'm done. I have listed all the terms of 12. I did the same thing earlier with 24. You might not have noticed it, but like 1 times 24, 2 times 12, 3 times 8, 4 times 6. There is no 5. The next number would be 6, but I already have it over here, so I'm done. Any set of factors at all, if you list them out in order, it will help you find when you're finished with them. Okay, so because none of these, like 1 plus 12 is 13, 2 plus 6 is 8, 3 plus 4 is 7, none of them equal negative 5, this is considered prime. Okay, this trinomial, it's a prime trinomial. Okay, because it cannot be factored. That's what that means. It can't be factored. So you're done. Your final answer to factoring it is negative 3x times the quantity x squared minus 5x plus 12. Okay, that is it. That is that trinomial factored as far as it goes. Okay, let's look at our patterns. Recognizing patterns will make you quicker. Okay, so these are those same patterns. I probably put the label, should have put the labels on there. Remember, we have product of conjugates, product of, or the sum of the square. Let's see, the square of the sums, goodness, and the square of the difference. And it says look for perfect square numbers. 1, 4, 9, 16, 25, 36, 49, 64, 81, 100, etc. Okay, so look for square numbers, because here's the thing. You're getting this part this time. Okay, this is what you're given, and you're trying to take it back to the factor, or to the product part. Okay, you're getting it already written out as one thing. You want to take it back to the product. So you want to look for square numbers in these places. Okay, so that's what we're going to see here in example 5. We're going to get some square numbers. So we have x squared plus 10x plus 25. Okay, so do we have square numbers? Yes, we absolutely do. We have to recognize that, right? That this is a square number and this is a number that's been squared. So we have to think, well, what's the square root of x squared? Well, it's just x. What's the square root of 25? It's 5. Okay. Then we have to think, is this a sum? Okay, because it's a longer one. So which of these is it? Is it the square of the sum or the square of the difference? Well, the dead giveaway is right here, if you recall. It's plus. Okay, so it's this one. So we have our a term is x, so this is going to be x plus 5 squared. And we're done. Okay, so then on the next one, we're always looking for squares. Always. So is there a square root to 4y squared? Yeah. The square root of 4 is 2. The square root of y squared is y. Is there a square root of 49? Yes, it's 7. Okay. This time we notice that this is a minus sign, just like this one is. So it's the difference of, or it's the square of differences, or the difference squared. So we're going to have 2y minus 7 squared. And that's it. Okay, in C. Notice this time we only have 2 terms. It's kind of a giveaway in this case that it's going to be our first one, the product of the conjugates. But again, we have to make sure, like, do we have both of these numbers have to be squares? They have to be squares. Well, is there a square root to 8? Is there a square root of 8? No, there's not. Is there a square root of negative 32? Oh, it's not negative, pardon me. See, I did that myself. Because it's already a negative here. So it's just the 32. See? I make that mistake too. But is there a square root of 32? No. But that's odd. There's 2 terms. Do you recall the previous note said to factor first? Find the greatest common factor first. We have 8a squared minus 32. Do 8 and 32, like, is there a GCF in there? Yes, absolutely there is. Okay, they both can be divided by 8. So we need to factor out the 8 first. So 8a squared divided by 8 is a squared. Minus 32 divided by 8 is 4. Now we can see our squares, a squared and 4. So what's the square root of a squared? Good, it's a. What's the square root of 4? Perfect, it's 2. So this time around, our answer, right, we're going back here, right, the product of conjugates, when we have just 2, ends up being a plus b times the quantity a minus b. But we can't forget our 8. So this is going to be 8 times the quantity a plus b. So a plus 2 times the quantity, the a minus b. So a minus 2. There is a lot to this section. I know that. Right? It's a long one. Okay. Last problem here is the word problem. So let's get into that. Again, work on those, memorizing those shortcuts. those patterns, I should say. All right, this next one, we are given a formula you are also going to use repeatedly throughout. Okay, negative 16t squared plus v sub 1 times t plus h sub, oh, sorry, I, not 1, h sub I and t sub I, or v sub I. Okay, so this stands for the height in feet of a projectile after t seconds is expressed by this polynomial. So it's the height in feet of a projectile. We're talking projectiles here. So negative 16 is a constant in feet per second due to the gravitational pull. V sub I, right here, is the initial vertical velocity in feet per second, and h sub I is the initial height in feet. Okay, so we're going to be plugging numbers into this equation to solve it. So example 6 relates back to this formula because a soccer ball is a projectile. So a soccer ball is kicked from the ground with an initial vertical velocity of 48 feet per second. Notice that's our v sub I. Express the height, we're trying to find the height, of the soccer ball as a factored polynomial. Okay, so express that as a factored polynomial. Okay, so when our soccer ball is kicked from the ground, okay, h sub I is the initial height. This is our h sub I. When it's kicked from the ground, how far off the ground is it? Good. It is 0, right? It's there on the ground. So we're going to plug these numbers in to our formula. So our formula is negative 16t squared plus v sub I, whoops, my board's messing up on me, v sub I times t plus h sub I. Okay, we know our h sub I is 0, and we know a v sub I. So we're going to have negative 16t squared plus v sub I is 48, so plus 48t plus h sub I is 0. Okay, which, we don't need the 0, so that's negative 16t squared plus 48t. And we're supposed to factor it. Okay, so the first step in factoring is to look for a GCF. Negative 16t squared and 48t. Do they have anything in common? Okay, and I'm going to take a little bit longer way to do this. Okay, maybe you see that they both have a 4 in common, right? So we could factor out a 4. But remember, we always want to take, if there's a negative on that first term, we want to take it out too. So we're going to factor out a negative 4. So negative 16 divided by negative, oh, and there's a t. I'm going to go ahead and take the t because they both have a t in common. Okay, so negative 16 divided by negative 4 is 4. T squared divided by t is t. 48 divided by negative 4 is going to give me a negative 12. T divided by t leaves me with nothing. Now, the reason I did this is because we don't always see the greatest common factor in numbers. So I would do this, and then I would look at my binomial and be like, wait a minute, 4 and 12 also have another, they can both be divided by 4. It's like, doggone it. So we're going to factor out another 4. So I've got this negative 4t that I factored out. I'm going to go ahead and factor out another 4. Okay, so 4t divided by 4 is just t. Negative 12 divided by 4 is negative 3. Okay, now the reason I did this is, again, so you could see. So now I factored out both of these terms. So I need to, and it's multiplication. So what is negative 4t times 4? Well, negative 4 times 4 is negative 16t times my quantity, t minus 3. And you may have seen right here that negative 16 and 48 had a negative 16 in common. A lot of times we don't, 16 is not a number that we're kind of like trained to see. So if you have to two-step it or three-step it to get the greatest common factor out, don't sweat it. You're doing perfectly fine. Okay? You're not always going to get the greatest common factor the first time, but just keep going until you have no more factors in common between your two terms in the binomial, okay, or the three terms in a trinomial. Doesn't matter if it takes you one step or three steps, okay, you're totally fine. Just knowing what to do after, because we took the negative 4t out and then we factored the 4 out, so we do have to multiply those back together to get our final term there. Okay, I know that was a lot, so have a great night and or a great day, whichever, and I will see you tomorrow.